Welcome to The Explainer. Today, we're going to dive deep into the story of the thinking machine. We're going to trace the long, really fascinating history of artificial intelligence. We hear about AI all the time, right? It's everywhere. But what is it really? If you want to understand where AI is heading, you first have to know where it came from. So, that's what we're going to do. We're going to trace its story from the very first dreamers to the huge questions we are all wrestling with today. Our journey actually begins not with silicon chips and glowing screens, but way, way back in the 19th century. We're talking mechanical gears, steam power, and a vision that was frankly astonishing for its time. Now, this quote, it comes from the 1840s. It was written by Ada Lovelace, who many consider to be the world's very first computer programmer. I mean, just let that sink in for a second. Long before a machine could even reliably add two numbers together, she was already imagining a future where they could be creative. You see, this whole idea of a computer, well, it didn't just pop out of nowhere. It evolved piece by piece over centuries. It all started with these simple mechanical calculators, like the one Blaise Pascal built. Then it took a giant leap forward with Charles Babbage's incredible designs. And it was finally hammered into reality in the fires of World War II, when Alan Turing and his team built the first real computers because, well, they had to. And here's the really wild part. Babbage basically had the blueprint for a modern computer, a full century before its time. And it was his partner Lovelace who was the first to really get what it could do. But the project was just too ambitious, too far ahead of the curve. The technology just wasn't there yet, leaving Lovelace as the very first programmer for a computer that was never even built. So, after figuring out how to build machines that could calculate, what was the next big leap? Well, it was trying to build machines that could reason. So you have this guy, a real pioneer in AI named John McCarthy. And back in 1958, he has this idea. What if we could build systems that were kind of like a detective? You give it a set of known facts, a set of strict rules for logic, and it could deduce new things with absolute mathematical certainty. Okay. That sounds cool in theory, right? But how do you actually test a machine that can reason? Well, you put it in a dangerous world. A classic AI challenge called the Wumpus world gives us a perfect little window into how this all works. So here's the setup. The agent is in a dark cave and can't see everything at once. It only gets little clues. For example, it might feel a breeze. From that one clue, it has to make a purely logical deduction. Okay, if I feel a breeze here, then there must be a pit in one of the squares next to me. See, it's not a guess, it's not a hunch. It's pure, cold, hard logic, used to build a mental map of the world and, hopefully, survive. But, and this is a huge but, there was a massive problem with this whole pure logic approach. The real world, it turns out, isn't a neat and tidy cave. It's messy, it's unpredictable, it's full of uncertainty. And strict true or false logic, it just isn't always enough. I mean, just think about it. How does your doctor really think? When you go in with a weird symptom, they don't work with absolute certainty, right? They can't. They have to play the odds. They have to work with probabilities. So for AI to actually be useful, to step out of the lab and into, say, a hospital, it had to do something different. It needed to move beyond just true or false. It had to learn how to handle shades of gray, to deal with degrees of belief. It had to learn the language of probability. All right, let's actually walk through this. Imagine you're an AI trying to make a diagnosis. First, you know that meningitis is incredibly rare. Your starting point, your prior probability, is just 1 in 50,000. It's super unlikely. Okay, so that's fact number 1. Now, fact number 2. The symptom itself, a stiff neck. You also know that, on its own, a stiff neck is actually pretty common. About 1 in 20 people might have one for all sorts of reasons. And then you add this third, absolutely crucial piece of the puzzle. The AI knows that if a patient does have that super rare disease, there's a 50% chance it will cause a stiff neck. Now, when you put all of that together, an AI can start to reason like a seasoned doctor. It figures out that yes, a stiff neck does make meningitis more likely than it was before, but the final probability is still incredibly low. This ability to reason with uncertainty was a massive leap forward. And honestly, this exact kind of thinking, it's everywhere now, from your spam filter to your Netflix recommendations. All right, so we're making progress, right? We've got machines that can handle logic, and now they can even handle probability. But What happens when a problem is so mind-bogglingly complex that you can't even write down all the rules? What if there are just too many possibilities to count? Well, that's exactly the wall a programmer at IBM named Arthur Samuel hit back in the 1950s. He was trying to get a computer to play checkers, and he realized he just couldn't program every single strategy. So he decided to try something completely radical. What if, instead of him teaching the machine could teach itself? And this is where things get really cool. The program started out knowing basically nothing about good checkers strategy, but by playing against itself over and over and over, thousands of times, it slowly learned. It figured out which moves led to a win and which led to a loss. It built its own strategies from scratch, just through pure experience. And get this, it did all of this on a computer with just 10,000 words of memory. That's less than a simple email today. This wasn't just another step. This was the birth of machine learning. It was a total game changer. This idea that systems can learn from data and from experience, instead of being programmed for every little thing, is the absolute foundation of almost all the AI we use in our lives today. So this whole journey, right, from clunky mechanical gears to programs that can literally teach themselves, it's all led us right here, to this moment. And now we're facing some of the biggest, most mind-bending questions we've ever had to ask. I mean, we're talking about things that used to just be in science fiction movies. As these systems get woven into the very fabric of our lives, we have to start asking, what are they to us? What is their place in our society? And of course, there's the big one, the one everyone talks about, control. As these things get smarter and more autonomous, how do we navigate the risks? How do we make sure that the future we're building is one that's safe and better for all of us? But you know, maybe the most incredible question of all is this one. We started this whole quest asking if we could build a thinking machine. But what if the real prize isn't the machine itself? What if it's what the machine's thinking can teach us about our own thinking? Maybe the ultimate gift of AI is that it's a mirror, showing us something new about ourselves, something to think about.